Hey folks, welcome back. So let's get ready. This is part 7 of this ongoing series about coding web UIs and the Arduino C++ code to control sensors and actuators with MQTT. So let's get going, shall we? First off, let me start with an overview of the changes I did since the last session. So as you might have seen, I was sending payloads to the hardware nodes via in a JSON format and parsing it with Arduino JSON. That turns out to have had some quite hard limitations given the small amount of memory that we have on there. So I went back to a hand-rolled format, and that enables me to set quite a number of sensors and actuators, as you can see. So I changed the internal format, some aesthetics, much better Arduino code as well. So I now sort of rediscovered in C++ function pointers. Well, I used them before, but it makes handling the various MQTT messages way more practical. So as you can see, I just have a simple map of sorts from command to the handler. So, I also hope the sound is going to be much better today. I have a new mic. Amazing. So, yeah, I hope that's going way better. And for today, we'll work on some little changes in how the servos are handled. So, right now, what is going on is, let me find it, handle. So, yeah. It's calling a function called moveTurnout every time it receives the correct MQTT payload, and it sets the PWM value to turn the servo. And that's all fine and dandy, but that's sort of a blocking function, and I have very little control over the timing. So what I wanted to try is to, and I started a bit on this, is to add the same sort of split timing thing here, so that in the main loop every given time we would update the servo position. So might work, might not work, who knows. Let's just give it a try. So first I'm gonna get a hold of this moveTurnout function, and I'm gonna copy it down there and also reuse pieces of this thing here. So I'm gonna comment this out immediately. The thing is, we might also need to implement a queue of sorts so that we can pile up all the current commands that we have received. So yeah. I don't want to do a too long video because that's not always the best idea, but we'll see what we can get done. So let's first do this. So I added previous time for servos. I'm not gonna reinvent the wheel for now. In a future video, I will very likely be showing you some other experiments I've been doing, which is, if I can find it somewhere, using basically a scheduler that allows you to do some fancy things with timing and running multiple functions at the same time on the ESP node, but that's for another time once we're sort of done with all these things. So current time servos, let's do that. Previous time servos equals this. So we're not going to use the poll interval because we want a higher refresh rate, well, a higher step rate than I think 200 milliseconds, which is the default for polling the sensors. So let's do it every 20 milliseconds to update the steps. The locked variable here is just used to not send anything, will not do anything when we're currently uploading or changing the firmware or changing the configuration of the sensors or actuators. So So what we want is to do it for the whole list of actuators. I'm gonna also reuse the code for getting the correct thing. So let me check. We have. So basically what we're doing is this right now. So this is a trigger, so this triggers a sort of command for an actuator. Command switch, this is what I call the servos. They're used in a specific case, that's not a problem. So we iterate through the list of actuators. I did a lot of debug. I had some strange data being set when I was using the JSON payload. That's normally fixed, but that's why there's so much print. I need to go back to a more compact debugging thing. So what we want here is, so if the actuator type is T, so turnout, that's for, well, this was made for model trains for the kids, so turns out are basically the switches on the train. And so if the pin is the correct one for the given command, and so the mount here for actuators and for sensors as well is where it is mounted. So let me show you. I'll switch to the camera view for a second. So you have two boards basically controlling things, sort of input output. So I don't know if this is going to be very visible. So this is a custom made board. I'll soon upload the files so you can also make this one. It's very cheap, like around €3 to make, and it has 16 inputs. You can also use them as output, but typically use as inputs. And we use some of these PCA, I always forget the exact reference, 9685 16 channel PWM drivers for controlling servos or LEDs and things like that. So if you go back to the code, so P means basically, I call it for P short for PWM, so servos and things like that. So let's just reuse this. So for each actuator here, that should still be valid. By the way, I have this PWM set PWM frequency because I tried using both servos and LEDs on the same board, and for that you need a different frequency. I'm not sure if this is the best idea. Let's just remove it for now, and we can always go back to it later. We don't need stupid debug messages. So we're not gonna do move turnout, because what we're gonna do is so basically we have two possible options. It's either fully to the left or fully to the right. This is what is being done for the servos. You could also control them directly like LEDs and setting a given value, but that's not going to be the case here. Previous state and thing like that is from older code. We don't really need that. So wait, let's just keep this whole thing, and we don't need that either. We're gonna remove it in a second. By the way, if you're bored watching some people code, I guess this isn't for you. But if you do love that and you learn some little things, then good. It's always more about learning the process and having fun while coding. So this means this would be going to the left, and what we are gonna change here also is, so this was doing all the steps in this loop. So what we actually want is to do a little bit each time this is called in the main loop. I'm also gonna remove this. We are gonna disable this anti-jitter thing. We're gonna add it back later. Without this, at the end of setting the servo position, it tends to jitter a lot and also overheat, like sometimes really badly. So I'm just gonna do some very basic thing. Sorry, so else if value, so that would be moving right. And we can just reuse this piece of code. And so yeah, we have the basics that we are gonna need to change this. So here we are using turnout, which is actuators at index I. So we could reuse that. I'm not entirely sure if it makes sense. Let's just go with this. It's simpler for now, because we already know we're at the current correct thing here. So let's think for a bit. What we need to do is have a way to track where it is exactly in the movement thing. I also added this mid position here, which is honestly not a good idea. This was supposed to be the middle, like when your servo is somewhat in the ballpark of centered. That turns out not to work well, but for now we don't want to change that, so let's keep it that way. So yeah, we want to be able to trace for all the servos that are moving where exactly they're at. So just a second, I need to double check something first. So what I always tend to do is hard code things. So it might be bad, but it's easiest to start that way. So let's use this. We're gonna assume we only have one server for now, and we're gonna move to something better down the line. We do have a struct to represent state. For now I used it only for sensors. We can create something specific if we need it to track where we're at. Just to be clear, I like clarity in naming things. So pulse length for the servo. So here it would obviously not be this, because what we want is this. Of course, this value here is the one, basically the direction. So I'm also going to rename this, again, for more clarity. And we need to store this when we are getting the mqtt command. So let's also comment this out because we don't need it. So pulse length servo, and we also want something. So if we're moving left, then we want to be sure that it's not going to overshoot. So basically it needs to be smaller than this. So basically mid times 2, which would be the full length of the movement if mid was actually the center. So if pulse length servo greater or equal than this, then we go back to 0 or not. No, let's do it the other way around. So we're gonna increase it. So let's just increase this one. And in this case, if it's above 0, we are gonna, you guessed it, decrease it. So the direction thing is something that we are gonna set in a really dirty manner, quite simply here. So we have some moves around value. So the value is gonna be direction equals value, and so we're just gonna hard code this as well. We could also go with a boolean because technically there's only two directions, but yeah, we can always change that later. So direction is being set here, and let's go back to where we were. So this means that every time in the main loop, yes, always in the main loop for now, every time the time has elapsed, we check all our actuators. We could do some filtering, some better things down the line, but that doesn't matter right now. That doesn't need to be redefined every time, so let's move it out. An unsigned int would make much more sense for that one as well, but anyway. So we have direction equals 1, so that's being set correctly, and it's just gonna increase every time, and it's gonna write it to that pin, and it's gonna set it to this value. So I think it looks good. Let's just already check if the current code is working before we upload this. I'm gonna start the terminal here as well. So let's just check. Let's go to control mode, and normally I need to also see, yeah, you should see the servo is currently moving. So let's go back to our code, and I never seem to recall. Yeah, it was exactly this. So let's go to this. We're using so I'm using platform IO. If you don't know about it, just do a web search. It's absolutely great. It's really a very good framework of sorts to deal with all your dependencies for your C++ hardware projects, Arduino type things. And you can set up in this configuration file some specific environments. So for example, I have OTA, so for over-the-air updates, remote things, specific configuration. You can combine things. Well, anyway, the point is we're using environment cable because we're connected via a USB cable to the ESP node right now. So let's try and upload and see if I did huge mistakes. Yes, and that's part of the game. So, oh yes, of course. It doesn't know in the loop the pin we're looking for. So again, I'm gonna cheat for now. Sorry about that, servo pin. We're gonna clean up something later, but anything that works is always better, even if it's hard-coded at first. Okay, so now it's gonna upload this. You should also see some connection disconnection here. Oh, surprising. I must have powered up some other node somewhere. Well, this is the one we're dealing with right now, the first one. Yeah, as you can see, it's offline now. It's gonna reconnect in a second. Let's see what's going on. There. No, it's back online. So let's see. It seems like something is working immediately, but then again, because I forgot to comment out the old way of handling this. So let's remove this, let's remove that as well, and re-upload. Honestly, live streaming, I don't know if it helps my brain or not, but it makes me kind of forgettable. Forgettable? No, don't mind me, not native English speaker, so forgetful is what I want. So let's see how that behaves. We can also add some monitoring here for this and see if there's anything. Well, we won't get any useful debug messages at this point, but still. And it's only working one way. Okay, let's see what messages got received. I don't know if it's actually visible in the video, if audible rather, but the servos are whirring quite badly. So so here, receive turn on command, pin 0, actuator type T, pin 0. Okay. I must check if we're actually getting the correct value. Wait, no, that used to work because we were able to move left and right, so no need to double check that. Let's go to the other things around. Direction equals 1. Boltzmann, This also makes more sense in the other direction. Let's remove any obsolete things for now. So PWM, set PWM, actuators, not I, not pin, Boltzmann should actually be correct. Okay, let's send another thing. I can see the servos whirring. Let me check. It might also be the speed, so every 20 milliseconds might not be the best thing. Interesting. So unfortunately I don't have a high resolution camera to observe the servos. They are moving left and right by tiny amounts. So what I'm gonna do is some really... Oh, wait, it actually worked. So you should be able to see, hopefully, that the arm here, I need to add some bright yellow or something to this one right here, because that's the one that's moving. So let's do that again. Let's move it left. Move it right. So it's wearing. I think the update frequency is just too low, so it's moving just by a tiny amount. So it's whirring, but it's not moving. I also just had my computer do a major hiccup, so wait. What are we doing here? So let's increase that frequency to every 5 milliseconds and see how that behaves. So it should still work. Boltzmann servo. This, by the way, should be actually moving all the servos. The other one doesn't have an arm, so it's not easy to visualize. And this just crashed. Let's do that again. CD, node accessories. Let's see if this makes it a bit more palatable. Yeah, I bet you really love to watch numbers go up, right? So interesting. So, how is this gonna behave? I also need to double check the heat of the servos. For now it's okay, because these are 3D printed mounts that use PLA, which is not the most heat resistant plastic, as you might have heard. So let's move this. Okay, that's much better. And it moves back. That's interesting. Okay. Okay, that seems to work. I hope you're actually able to see that. Wait, I'm gonna put something in there so that you can actually see the movement, hopefully. Let me check if that's actually visible. Really need to change this hardware setup somewhat. So let's see if that is gonna work as expected. Yes, it moves. Well, this seems actually to work quite well. There's some delay, but it does work. Yay, amazing. So this is kind of reassuring. Okay, that's good. So it doesn't try to move it again when it reached the maximum position. Okay, so what we now could also do is next time I think modify this and set it to a variable that you can actually set, so not having to recompile things in order to change the timing of your servos. You're gonna see at some point in a much later video, I think, to be honest, all these things in action and where they all fit in and how they move. So they're supposed to be slowish, so it's kind of a good fit, I guess. So let's try this again, a bit faster now. I could also set up speed parameter for servos, which would sort of allow, like, I'm not a generic thing, but it would allow them to skip some beats and update accordingly. Like, we could update every 1 millisecond and they could just skip that and something like that. Okay, that still works and it's kind of good. Okay, I think just to, before we end the stream, what we can try and do is, well, add it in a way that's a bit less dirty, so specific to each servo. So let me think for a second. Yeah, amazingly, just coding doesn't work. You actually have to think before you code, which makes this live streaming thing sometimes so awkward. But yeah, hopefully the sound is already way better. Let's move the mic even closer. Yeah, after 20 minutes. Let's see. So, oh yes, before we do that, what we might want is if it reaches this, then, and also for the other extremity, we can also do this cleaner at some point. We want it to disable the jitter. So honestly, I don't think it's visible or audible here, but it's really quite important that we do this correctly. Let's do the whole thing in a more coherent manner. So we just want it to shut down, and of course it was the same here for both cases. So this should now turn that off. Of course I need to update that. There you go. And yeah, I think we can just add a small struct to keep that. We're also using this all the time, so we're looping through all these, every single loop. What we actually would want is there a command? Did anybody actually request some change? If they didn't, it then doesn't even make sense to do this. So that's another improvement that we could do. So let's just first upload this. We don't need to really bother with that. It's just gonna work hopefully as expected. Let's also remove this. So yeah, let's add a small struct for here. Struct. How could I name this? Actuator state, I guess. What we want is, no, let's make it even more specific. Two generic things are not good when you start. So let's use ball direction, and let's use this To define the PWM thing we have here, where is it? Pulse length servo. So this means they will both have this. I would need to create these on the fly, basically based on what actuators we have. I'm not the biggest fan of that, so I'm gonna do a different sort of hard coding. Yes, you guessed it. So let's use this servos, and we have 2 for now, and we can get rid of this. And so what we want is here, instead of just setting the direction, is, yeah, the hard coding is going to be really weird, but let's just assume that servos 0 is if actuators pin, I think we have one on pin 0 and one on pin 1. Let me check. Yes, so let's do it that way. So if it's 0, we're gonna set it to, we're gonna set the state of servos at the index 0. So this is equal to value, and let's just copy and paste that for now. So if it's pin 1, then it's the second. So this means we have that set. Let's go see directions, which is so we're gonna need to do that a bit differently. Let's just comment this out. So we actually need to do some separate thing. I really don't like this. This is not ideal. We really need to redo this because it will make it a bit cumbersome. But anyway, so if it's the first servo, then we're gonna use the direction here, and so we could just copy this, and you're gonna see what I'm getting at a bit. So let's move this. So we're gonna reuse this one. So if the direction is that, then we're gonna do this. So the pulse length servo needs to be servos this. So as you can see, it's all using that specific instance of a struct information, because you need to update the whole specific things every time. There, and there. So normally this will only work for servo 0. So we could, I think, just extract this into a function, or perhaps deal better with the other thing. I think for now, in order not to keep this too long, we can do this. We should already be able to control servo 0. Just a second. What we can do is try to see if we can watch the movement from So it's kind of strange right now, none of them are moving, so I might have messed it up with the with it turning off. So let's remove that, try again, and try to understand where the issues come from, and try again and again. Okay, let's just upload this. Normally we should be able to manipulate the main servo. So servo pen was not declared in this scope. Oh yes, of course. Well, you know what? Hardcode this. So that should work. Let's see about the rest. I forgot something. Oh yes, of course. After that, server state has no member. Of course, it's not pulse_len servo anymore. It's just pulse_len again. So there, we should be able to upload this. Yes, it seems to work. Yeah, I really don't like having to have some specific struct for each type of thing. But overly generic code also doesn't tend to work that well. So let's see if this works. Okay, it's connecting right now, as you see this there. Yeah, there's quite a lot of queries being done. Whenever a node connects, it notifies the UI, which sends a message, hey, please send me the list of sensors and actuators you have. So it automatically updates the UI. So that's not doing anything apparently. So let's see what's going on. Debug. Let's see, could it be that we are not setting this correctly? So actuators, so the pin is 0. So what we received here, turn on command pin 0, actuator type T, blah blah blah. So pin 0. So we can add a little debug message here. Setting servo 0 state. And it's setting the direction. I do wonder if we need to cast it. Not entirely sure. So let's add also a debug thing for that. Just check the direction. Servo 0, the direction would be this. So let's first check this one out. Re-upload, repeat. Not the most friendly debugging, but it's not so bad. Come on. We want to do this before the end of the video. Okay. There you go. Okay, so what does it send here? Setting servo 0 state 1 and the other one state 0. So that should work, I guess. 0 and 1 being correctly evaluated as booleans. So we do have the correct state in there. So let's see. It might be the actual handling here. Oh, and also we don't need any of this anymore. So just remove it. Actuator spin is 0, blah blah blah. We are double testing, but as you've seen before, it's because of the way we're doing it in a hackish way so far. Okay, this is not very elegant, but let's do it anyway. So that would be, we can even do it here and do this. So moving servo 0 direction, and we're gonna add that. So servos at index 0 dot direction. We could also check if we are correctly setting the pulse length here. So let's do that. And so that would be the pulse length of the current servo. So let's upload this. I really do like to finish videos on a note where, hey, it works, amazing. So let's see if we can actually manage that. So where are we at? Okay, just disconnected, should be back online in a second. Let's see also what's going on. Of course, it's gonna spam this right there, and hence the need to actually make this based on a command. But anyway, so, oh, well, that's interesting. So it should be working. Move left, and this should go back down, I guess. That one down, and move right should move it back up. Okay, that seems to work as expected. So let's just remove this whole debug thing for now. So Peterman actuators pin. Well, honestly, I'm a bit baffled about this. It should be working as expected, and yet it doesn't. Because we are setting the correct pin, we already know that. We are using the correct pulse length, we can see it's changing. So if I go up, it should be 0, and of course I can't go that far up. You know what? In order to avoid spamming and have something more complete, I'm gonna do not a bad hack. Ooh, bad hacks day. I'm gonna do something like bool command received false for now, and we're gonna set it to true as soon as we have received something here. So we're just gonna do this for this one. Yeah, it's a very restrictive check, but whatever. So now we can do this and command received, and it should be also command received and treated, because we're gonna set it to false once it reaches the end. Am I actually? Yeah, it should be. So command received equals true. Amazing. We can do the same thing with the other one. So it should work as expected. So this just shuts it down. Of course, it should be the other way around. And we can add the debug again, because it should only spam us when we actually want to be spammed. Spam, spam, spam. Please upload faster so that nobody's bored. By the way, I'm really thinking if these videos wouldn't be better served in a non-live format, but it's really so hassle-free. Just click a button, set up your hardware, and done. Okay, move left. And of course, if I don't monitor what's going on, I won't ever know what's happening. Move right. So that's doing exactly what it should. Note where it ends. So left. Well, that's stopping right where it should. So could I actually have messed something up in the hardware, which is not impossible. There's always a need for additional power supply here. Okay, not obvious. Because if the problem ain't software, it could just be hardware. So, I'm not seeing anything obviously wrong here. Neither of them are moving, that's for sure. Well, I might just have no other choice than stop the stream here, although, man, it's way better when it just works. Perhaps, no, we're having the correct pin, we're having the correct pulse length. So that's really odd. Also, if I actually edit these videos, you could watch me in accelerated mode, missing my head and banging it against the wall until I figure something out. So it's setting the PWM correctly, servo's pulse length, it's doing that here as well. Weird, really weird. So. Nope. Still no movement. And still no movement. Moving servo, it's actually displaying all the correct intermediary values. So very odd. One last try. So moving servo 0 in direction 0, and it's setting the pulse lengths correctly. I do see some quite severe jitter still. Oh well, I guess we're gonna have to call it a day. This is kind of a bust, but there's always next time. And as usual, I'll figure it out and let you guys know what was the problem, or if I still want some people watching me bang repeatedly, then I can do that next time. So thanks for watching and see you soon in the next episode, which will work way better hopefully. Bye.